So, when we're trying to solve quadratics, what are we trying to find? What exactly are we trying to find? We're trying to solve a quadratic. If you're trying to solve anything, you're going to end up with a what? Starts with an S. Solution. What's another word for a solution for a quadratic? Solution is literally the better word for answer, so no, not quite. What's another word for a solution to a quadratic? Where are the solutions? Not the x and y intercepts. The x-intercepts. That's what we're trying to solve for here. What's another word? No. No, 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 no. No, 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 no. These are the solutions. There are no more solutions on this graph. Zeros. And there's one more word that everyone seems to forget that starts with an R. Starts with an R. Very short word. No. R-O? O? Roots. Roots. We're looking for the roots. Rotations. That's funny. Oh my God. All right. Now, last class, what did we learn how to do? Factor. What's the point of factoring? Why do we do it? Why do we factor? What multiplies to be negative 8 but adds to be negative 2? What multiplies to be negative 8 but adds? Not negative 2. Yes. X minus 4 and x plus 2. These are the factors to this little quadratic. Why the heck did we do this? What's the point in knowing what multiplies to give you a quadratic? I know I said it last class. Oh, I know. It was so long ago. Oh, well, I guess it was 2 classes ago. Once we factor, we can easily find the what? We factor so that we can solve, meaning find those solutions. Find those x-intercepts. How do we do it? How do we take factors and find solutions? I'll give you a hint. It has something to do with this. Set each factor equal to 0. Yes, because these are our zeros. Another word for solution is a 0. So here our solutions are x equals what? What's our first solution? So how do we get the x by itself here? Yes, you add 4 to both sides. So what is x actually equal to? A positive 4. And what's our other solution? Good. These are our two solutions. This is how we solve a quadratic. Meaning that this quadratic intercepts at -2 and 4, like this. It looks like that. That's what we're doing. That's why we factor. Is so that we can figure out our solutions, our x-intercepts, our zeros, our roots. That's the whole point. Now, does every single quadratic factor? Nope. Because do you think that it's guaranteed a quadratic goes through a whole number? No, for sure not. It could be any point, any decimal between two whole numbers. Anytime you have a quadratic that goes through something crazy, you won't be able to factor it. What do you do when you can't factor? What do you do when you can't factor? Yes, you use the quadratic formula. Thank you, Carolina. The quadratic formula is what you use when you cannot factor. At 10:45, so after this class. Oh wait, when does this class end now? Okay. We use this when we can't factor. So, let's try to factor this. Up top goes what? Which is? And what goes in the bottom? What multiplies to be 15 but adds to be 13? -13, sorry. Does -5 plus -3 add to be -13? Nope. Does -15 times or plus -1 add up to be -13? Nope. Are there any other factors of 15? Nope. So guess what, guys? We can't factor this. We can't factor, so what do we use? The quadratic formula. We use the quadratic formula. Does anyone remember the quadratic formula or using the quadratic formula? Raise your hand if you've heard of the quadratic formula. Okay. Okay. It's okay. This is the quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. Everybody read it with me. Negative b plus or minus square root of b squared minus 4ac all over 2a. That was pathetic. That was real good. You need to know this formula. You should have used this a whole bunch in Algebra 1. It should have been drilled and killed into you. It should have been sung to you. You should have memorized a song, any of this. Okay. It's okay. I don't know a song. I just remember it. I know that teachers do songs. No one remembers a song? Let's try to find the solutions of 2x squared minus 13x plus 15. What is our a value here? 2. Just the a. The a is just the number in front of the x squared. What's our b? Negative 13. And what's our c? 15. Now, if you're looking inside of the square root in the quadratic formula, we're given b squared minus 4ac. This is called the discriminant. This is called the discriminant. The discriminant helps you determine what type of solution you're going to have. Whether you're going to have 2 solutions, whether you're going to have 1 solution, whether you're going to have no solutions. The discriminant will let you know this. Now, it's asking the value of the discriminant for this problem is blank. So what we're going to do first is we're going to find what the discriminant is. What b squared minus 4ac is equal to. Now what's our b value? So we have negative 13 squared minus 4 times a. What's our a? 2. What's our c? 15. So now we're going to put this entire thing in our calculator. We have negative 13 squared minus 4 times 2 times 15. And we get 49. Because this is a positive number, we will have 2 solutions. We're going to end up with 2 solutions. So now what we do is we finish making our quadratic formula. Remember, this is our quadratic formula up here. X equals negative b. Now what's our b value? What's our b? Negative 13. Plus or minus the square root of b squared minus 4ac. Now, what did we find b squared minus 4ac is? 49. So I'm just putting that in my formula. All over 2 times a. What's my a? 2. So I need to simplify this now. What is negative 13? A positive 13. What is the square root of 49? Does that evenly square root? It's 7, yes. Square root of 49 is 7. What multiplies by itself to equal 49? 7. 7 times 7 is 49. And what's 2 times 2? 4. Now, we have to separate this into two solutions. What do you think the first solution is going to be? How can we find our first solution? We can take 13 plus 7 and put it over 4. What is 13 plus 7? Now, I'm not going to write a decimal here. I'm going to leave it as a fraction. Oh my God. I'm over here thinking like, oh yeah, these don't divide. Wow, it's been a morning. 5. Thank you, Mark. But it doesn't go to a decimal. You're so right. And then how are we going to find our second solution, you think? Subtract now, because there's the plus or minus, meaning we have to take into account both of those situations. Now what's 13 minus 7? Can we divide 6 by 4? No. What does this simplify to? Yes, because 2 can go into both of these. 6 divided by 2 is 3. 4 divided by 2 is 2. So we have 3 halves. So these are our two solutions. X equals 3 halves and x equals 5. How many solutions did we end up with? 2. Are they real or complex? Meaning, did we end up with a negative value as our discriminant? No. Only when we have a negative value for that b squared minus 4ac, that's when we get imaginary. So these are real. Imaginary is only when the discriminant is negative. Both will be imaginary. Okay. So I'm going to help you on this. I'm going to help you get started on this next one. Is this x squared plus 6x equals negative 9? Is this in the correct format? No. What does it need? What do we need to do? What do we need to do first to get this to be in the correct form? Standard form. What's wrong about this? What is different about this one versus this one? I think I skipped one. Not everything is on the same side. So what do you think I have to do? Are there like terms to combine? No. No. Get everything to the same side. How do I do that? Add 9 to both sides. So I have x squared plus 6x plus 9 equals 0. You guys try to find the solutions here. Go ahead. Try to find the solutions. What was your A value on this problem? What was in front of the x squared? If there's nothing, there's an invisible what? 1. What was your b value, Josue? What's your b value in this problem? 6. And what's your c value, Mark? 9. So what did we do first? What did we find first, Sydney? We found the, what is this thing called? The what? It starts with a D. Discriminant. Yes, we found the discriminant. By plugging in B, which is 6, then squaring it, minus 4 times A, which the A is 1, times C, which the C is 9. And we can put this in our calculator. So we have 6 squared minus 4 times 1 times 9. I really didn't need to put the times 1 there. And what should you guys have gotten? 0. So now I take that 0 and I plug it into my full formula. My negative b plus or minus the square root of the discriminant, which is what we just found, all over 2a. So x is going to equal negative b. I guess I'll write the formula. So, x equals negative b, which our b was 6, plus or minus the square root of what we just found the discriminant to be. What was it? 0. All over 2 times a. What was our a? 1. Now, we have to split this into 2 things. A positive and a negative. So we have negative 6 plus or minus, what's the plus, what's the square root of 0? 0. So negative 6 plus 0 all over 2. And then we also have negative 6 minus 0 over 2. What is negative 6 plus 0 divided by 2? Which is negative 3. What's negative 6 minus 0 over 2? How many solutions do we have? Just 1. These are the same number. So how many solutions did we have? 1. What do you think could have told us we were only going to have 1 solution? If the discriminant is 0, we will have only 1 solution. Was the discriminant negative? No, so it was a real solution. Now, what did some of you guys notice about this problem? What could you have done? What could you have done here instead of quadratic formula? This quadratic was factorable. You could have factored it. So you didn't have to do all of this work, but I just wanted to show you, you can use the quadratic formula on any problem. Not all quadratics factor, but they all can use the quadratic formula. But factoring is less work. So it's up to you. Now, I want to show you example 3. Can I immediately use the quadratic formula on number 3? No. What do I have to do first? Get everything to one side. So I'm subtracting 6x over and I'm adding 12 over. So it becomes x squared minus 6x plus 12 equals 0. So what's my a? 1. What's my b? Negative 6. And what's my c? What do I do first? And what's my b? Minus 4 times a. What's my a? And what's my c? And what do I do with this? Put in the calculator. Negative 6 squared minus 4 times 12. Negative 12. This is where we have an uh-oh moment. What did I say happens if our discriminant is negative? What are the solutions? Yes, the solutions are imaginary. Meaning there are no real solutions, but I hate to tell you guys this, there are what is called imaginary solutions, and we do need to find them. What this means is, let me show you. This quadratic does not go through the x-axis. Does this mean that the quadratic is not there? No, it just does not go through the x-axis. Now, the reason why imaginary numbers, imaginary solutions were created is because when you're solving great big world problems, sometimes you're going to solve and get imaginary numbers. If they just stopped and didn't keep solving, didn't keep a placeholder for this imaginary number, we wouldn't have things like GPS. Shh. We wouldn't have a lot of the technology we have today. Because eventually, when they keep solving these big world problems, the imaginary numbers will go away. So it's kind of like a placeholder in the meantime. Without imaginary numbers, we wouldn't have GPS, we wouldn't have all of the technology we have today. Because of imaginary numbers. They're like a placeholder because all of these big math problems used to compute GPS and I don't know what else. I used to know. I've totally forgotten, but GPS is the big one. If we didn't have a placeholder, if they just stopped, these problems could never have been solved. Instead, they created imaginary numbers as a placeholder, hoping that eventually in the math problem, the imaginary numbers would cancel out, and they did. So that's why we have imaginary numbers. So, how we deal with imaginary numbers. I want you to go back in your notes. Go way back up here. Where was this? This was day 1. Page 5. Imaginary numbers. We use I to represent an imaginary number. Now, I is actually equal to the square root of -1. I. Instead of writing the square root of negative 1, we write I. Because, tell me, what is the square root of negative 1? Remember, when we're square rooting something, we're asking ourselves, what number times itself will equal negative 1? Will negative 1 times negative 1 equal negative 1? No. Will 1 times 1 equal negative 1? No. It doesn't exist. It's imaginary. So I is equal to the square root of negative 1. Now, what is the square root of 144? 12. The square root of negative 144, we can think of these as being square rooted separately. The square root of the negative and the square root of the 144. Now, what did we say the square root of 144 is? And what did we say the square root of negative 1 is? I. So the square root of negative 144 is 12i. For part B, what we have to do is we have to first simplify this radical. How do we simplify radicals? We create our what? What did we do to simplify radicals? We create our factor tree. Yes. Now what goes into 360? Honestly, if I was you, anything that ends in a 0, what do you know goes into it? Anything that ends in a 0. 10. What times 10 gives you 360? 36. What can we factor 36 into? 6 and 6. Remember, I told you we're looking for pairs in our factor tree. As soon as we see a pair, we can stop the branch. What goes into 10? 2 and 5. So what does this simplify to? What goes on the outside of my square root? 6, my pair. And what goes on the inside? Which is 6 square root 10. So what do you think the square root of negative 360 is going to be? What do you think the square root of negative 60 is going to be? Remember, how do we deal with the negative inside the square root?
We don't.
Yes, we do. What did we do? We make the negative an I. So what is our square root of negative 360 going to have in it? No one has an educated guess for what our answer is going to have in it. Instead of it just being 6 square root 10, what should there be? Now that there's a negative in the square root. An I. There's going to be an I in the answer. The I always goes after the number outside of the square root, like this. Whew. What? Is that not how you draw your eyes? Okay, so technically print eyes are like this. Yeah. Just really quickly, what do you think I squared would be? Remember, what is I equal to? What is I equal to? The square root of -1. So if we're squaring I, technically that's the square root of -1 times the square root of -1. What is the square root of -1 times the square root of -1? -1. -1. If you multiply the square root of 3 times the square root of 3, it equals 3. Anytime you multiply a square root times itself, it's just the number inside of the square root. So I squared is equal to -1. This is why we do imaginary numbers, because eventually when we do more math to them, they become real again. -1 is a real number. This is why we have imaginary numbers. So just really quickly, what do you think -12i squared is going to be? Let's do it separately. What's -12 squared? What's -12 squared? Okay. What's 12 squared? Colton, what's 12 squared? What's 12 times 12? $144. What is I squared? Did we just learn, Madison? -1. So what does this become? What's 144 times -1? -144. Nate. You were so loud right out there. All right, I want you guys. Actually, I'll do this one, example 2. Now, we're simplifying this radical. The first thing I'm going to do is because there's a negative, I'm going to split this into a +32 and an I. Because there's a negative in front, the very first thing I'm doing is splitting this into 32 and I. Then I factor 32 like normal. What goes into 32? 4 times 8. What goes into 4? 2 and 2. What goes into 8? And what goes into 4? What are my pairs? 2 and 2, and also I'm going to circle I, because I's always go on the outside as well. So what goes on the outside of my square root here? Not just one pair of 2's. How many pairs of 2's did we have?
2.
So 2 times 2 with an I. And what goes on the inside? A leftover 2. What's 2 times 2? So our end answer here is 4i square root 2. I want you guys to do the example number 1. Remember, we found the discriminant was a -12. So now our next step is to finish creating our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We have a negative b value, which is negative 6, plus or minus the square root of, what did we find the discriminant to be? Negative 12. All over 2 times a, which is 1. So first I'm going to simplify this. What's negative negative 6? Positive 6 plus or minus. What did we just find the square root of negative 12 simplifies to? Remember, we split it into 12 and I, and then we split the 12 into 6 and 2, and then we split the 6 into 3 and 2. And we had a pair of 2's, so what did it become? 2i square root 3. All over 2. So then you're going to have two answers. One where you're adding, and one where you're what? Subtracting. So x equals over 2, and x equals, whoops. Now, if all of your whole numbers, the numbers outside of the square root, are divisible by something. For example, we have 6, 2, and 2. If they're all divisible by something, you need to divide. 6 divided by 2 is how much? I'm running out of room. So this is going to become 6 divided by 2 is 3. What is 2 divided by 2? So I'm left with what? I square root 3. Notice I divided 6 by 2 and got 3. I divided 2 by 2 and got 1. You divide 6 by 2 and you get 3, and you divide 2 by 2 and you get 1. So you end up with 3 minus I square root 3. These are your two solutions. You leave them like this with i's in them because they're imaginary. And you're done. So how many solutions were there? Technically 2, but they are what? Imaginary. All right, go ahead and try. Shoot, I don't know which one is imaginary. Yes. Try number 1, guys.